Buongiorno a tutti e con questo seminario dove abbiamo invitato Willy Tinner riparte la nostra attività molto intensa come è stata l'anno scorso di seminari rivolti anche fuori del nostro Ateneo, rivolti anche a un'audience internazionale su tematiche di interesse molto vario ma principalmente coinvolgenti aspetti del mondo naturale, del mondo geologico che riguardassero il passato, ma anche che ci dessero insegnamenti fondamentali sul futuro. Noi abbiamo avuto la fortuna che il professor Willy Tinner ha chiesto di passare alcuni mesi in sabbatico qui da noi, anche se purtroppo il periodo non è stato felicissimo e quindi potete immaginare le traversie che ha dovuto attraversare in questi mesi. E io credo che molti di voi Willy Tinner lo conoscano, certamente è uno tra i più rinomati Paleoecology e studioso dell'evoluzione della vegetazione del sud Europa, dell'Europa e anche del Mediterraneo, e ovviamente è responsabile di numerosi progetti a livello nazionale ed internazionale, ma io ve lo voglio presentare con un aneddoto abbastanza semplice. In realtà io e Willy non ci si conosce benissimo, ci siamo conosciuti meglio negli ultimi anni, ma io l'ho sempre sentito nominare dai miei colleghi palinologi, francesi, spagnoli, italiani, chi si occupava di carboni, eccetera, eccetera, sempre un po' come questa figura che aveva dato all'analisi paleocologica una visione moderna, una visione statistica, una capacità di interpretazione del dato che partiva da un'analisi rigorosa del dato stesso e non soltanto di tipo qualitativo. E devo dire che questo certamente ha permesso e permette tuttora delle letture nuove ed originali dell'evoluzione della vegetazione, e sicuramente questo si deve anche agli studi effettuati da Willy Tinner, che abbiamo la fortuna che ci terrà sia questo seminario, ma ci terrà il 26 anche un altro seminario, e chiedo a Tinner in diretta il 26 se lo volevo fare introdurre anche dal presidente INQA italiano, perché vi ricordo che nel 2023 è previsto, forse 2024, il congresso internazionale sullo studio del quaternario, e questo seminario, come il prossimo, è stato chiesto direttamente da INQA che venisse inserito all'interno delle attività di preparazione per quanto concerne in preparazione di questo congresso che si terrà nel 2023 a Roma. Tenete presente che l'ultimo è avvenuto nel 1953, quindi addirittura tenuto una parte qui a Pisa, quindi c'è, se volete, anche un filo affettivo importante, storico tra questi due eventi, soprattutto in considerazione dell'importanza che gli studi sul recente passato oggi hanno anche nella definizione del rischio su quello che sarà il futuro dell'evoluzione climatica. Ringrazio anche il CIRSEC per aver contribuito all'organizzazione di questa iniziativa, e come al solito ringrazio Bernardo Carmina per il SID, per la sua sempre maggiore unica disponibilità nel supportare la parte tecnica di questi seminari. Stiamo andando contemporaneamente in diretta su YouTube. Invito tutti a spengere i microfoni e le telecamere per dare più banda, ma soprattutto per non disturbare la presentazione di Willy. Ultimo aspetto tecnico: quando finirà l'intervento è possibile fare domande sul canale Teams o scriverle anche su YouTube, in quel caso me le leggerà probabilmente Bernardo. Quindi se non c'è ressa basta staccare il microfono e fare domande, oppure c'è la possibilità di alzare la manina, e come vedete sulla barra degli strumenti c'è una manina. Se alzate la manina io controllo e vi do la parola, ok? Quindi vi ringrazio e lascio la parola a Willy Tinner, e ancora con la soddisfazione della sua presenza, si fa per dire, in questo momento a Pisa, e soprattutto della disponibilità a contribuire con questi due seminari. Vi ringrazio e prego Willy.
Grazie mille Gianni per la gentilissima introduzione e anche per l'invito per poter essere qui con voi. Farò la presentazione in inglese perché purtroppo in italiano mi mancano i termini tecnici, e perciò vedremo adesso, seguendo il titolo, cosa ho preparato. So the talk is about legacy of prehistoric land use and climate change for future European vegetation dynamics. So I will focus especially on the vegetation part of the legacy. So I have troubles going down. So now, first slide. I succeeded, very happy. So legacies, there are many different legacies. Here we focus on environmental legacies, no kind of human legacies. And I would like to make two differences between ecological legacy and anthropogenic legacy. So why these? Because we will have then case studies that introduce these two differences. Ecological legacy is all what is natural from the past and has some effects on current ecosystems, on extant ecosystems that are still present, and through that, of course, also on the future. So to say, this is the memory or carryover of the ecosystem. Anthropogenic legacy, on the other hand, is all things which in the past were influenced by human disturbances, and these past human disturbances still have effects on today's ecosystems. So to bring an example, which is very easy, is from biology, is evolution. So everybody, of course, knows that we are affected by legacies as individuals through the evolution. There is an unbroken chain from us back to the very far past, millions and billions of years. And this chain is really affecting the present from the past and also the future, of course, through evolution. So this is very obvious to us through the contribution of Darwin and other researchers to biology and evolution. But the question here remains, is it also true for something which is more complex than in an individual? For instance, for populations or even communities, even more ecosystems or biomes, so at the continental scale, through the interactions between the individuals and of course through the interactions among the individuals and their environment. Paleoecology is a brilliant tool to assess such questions because it offers the possibility to reconstruct dynamics of ecosystems, of populations, of biomes, whatever, through natural archives in the past and through the multi-proxy approach. So the natural archive is what you see here, for instance, a lake, or it could be the ice cover, or it could be a stalagmite. And in this natural archive, there is information stored that we can exploit, that we can analyze. And if we do that with different proxies, like here on top, there are chironomids, or from the ice, there are the oxygen isotopes, or from some layers we could extract ancient DNA, fossil DNA, genetic, paleogenetic information. We could do model simulations, or we could look at other things like bones of big animals that existed in the past. If we combine these all together, we get a really efficient time machine, which allows us to go back and to look through history in a very continuous way, because the archive is continuous, what happened, and to explore such potential legacies on the present and the future. So I will come to the first example, which comprises the ecological legacies of the glacial interglacial cycle. So this is an example of natural legacies that are still active today on ecosystems. And I will focus on temperate ecosystems of Europe. What you see here, this circle is the classic glacial with frozen conditions, interglacial cycle with warm conditions. And you see here, important and interesting for vegetation, the biomass, how it goes. So very low biomass or no biomass if there is ice cover, and increasing biomass at the beginning of the interglacial, maximum biomass, and then through cooling and probably also drying, we have decreasing biomass, and we are turning into the next ice age, and so on. So one ice age follows the other one, and warm periods like interglacials follow the other ones. And if you look at this graph, which looks like a clock, basically it suggests that there is resilience in the system, because the things come and go, but there is a cyclicity. So according to this graph, the ecosystem would be able to adjust to climatic changes which are drastic for Europe, plus perhaps 10 degrees Celsius or minus 10 degrees Celsius over millions of years. If we look to the details, we see that it's not just biomass. There are different species, there are different taxa that come and go through these cycles, through the glacial, interglacial cycles. These are three interglacials that you see here. The penultimate, the last interglacial, which would be the Eemian, and the current interglacial. So you see the date, 300,000 years, 120,000 years, or the past 15,000 years. And what you see with colors, it's amazing. It looks like the same patterns, the same dynamics are reappearing always. For instance, at the beginning of the interglacial, there is always a boreal phase with betula and pines. And you see that. Or then the Thermophilus, Ulmus, Quercus, Tilia, temperate species are coming in all interglacials, and hazel, corylus is also peaking at some point in the interglacials. And this is kind of a mechanistic pattern. What is actually driving this, if you think this is so amazing? In 100,000 of years and in between are ice ages. We know today that this is astronomy, these are astronomic parameters, orbital parameters that are forcing the climate system to act regularly, and through the ecology of the species and the physiology of the species, the pattern re-emerges in the interglacials. Of course, there are differences between the interglacials, which are also marked here. For instance, Carpinus, you see here in this one from England. But altogether, it's kind of a mechanistic, amazing, resilient behavior of the ecosystems, able to adjust to different conditions, very different climatic conditions through time. But this is just one part of the story. Actually, the more interesting part, which affects two-thirds of the species of the European forest, is hidden. And this is a kind of a legacy. If you look here, so we are moving here from the tertiary, that would be before the quaternary, here somewhere through the ice ages. This would be these blue things, it's just a few are labeled here. And there is a taxa list on the y-axis here. And if you look at that, in red, you have here what we lost in Europe. So these are all genera or kind of genera. If it's type, then it's a pollen type that we lost through time. And we lost two-thirds of this taxa. Like, who would ever think that liquidambar is native to Europe? Or, for instance, tsuga or taxodium and Parthenocissus. So there are many different things that in Europe went extinct through the ice age cycles. So you see they are fading away. We are losing them as we reach the present here. That would be the Holocene or the current interglacial. And left are only just 11 major post-glacial forest formers in Central Europe, that's now north of the Alps, that actually suggest that the European temperate ecosystems here are very much impoverished. Why do I say impoverished? Because this actually leads us to the question, the legacy question. Is there an ancient European vacant niche legacy? So if we lost all the species that are still there in North America and Asia, and you see the empty pot on the right here, that would be Europe. This could make, and this is one of the hypotheses we have, Europe, because we lost all these species, two-thirds about, through the glacial interglacial cycle, would make Europe more susceptible to invasions by exotic alien species, so to say, that we consider alien, but actually they had very close relatives formerly in the European ecosystems. And this would just be something that climate acted on the legacy that is important today for conservation and nature protection. So invisibility of species that could make Europe more susceptible. So this was an example from the natural system. We now go to the anthropogenic legacies. The first that I would like to bring is the extinction of temperate interglacial mega herbivores in Europe. So there is a hypothesis which is actually very interesting, and it is the so-called Vera hypothesis, which says that by nature, today's European vegetation would be open, or far more open than we believe. Because what happened is that the mega herbivores that kept the forest open or the landscape open, they went extinct. So the natural vegetation, if we consider the time previous to the immigration of modern humans, would then be more like a parkland or something which is very open. And what we think today is natural disclosed forest, they would just be an effect of very early extinction, perhaps by humans, or that's actually what the Vera hypothesis refers to, of these mega herbivores. What we see here on this picture is a Eemian reconstruction, so 120,000 years ago, and you see the people there, but these are not human Homo, it's Neanderthal humans that are hunting with spears and hunting, and what you see in the background, these are European forest elephants. So it's not mammoth, that's interglacial, so it's the warm adapted fauna to Europe. So is it possible to address this hypothesis? We can do that with bones of elephants that are around, of course, and were found, so we know how these guys were. Amazing elephants. By the way, the European elephants were larger than all the elephants that we have today. And the assumption is that they would still be here in the Holocene if they didn't go extinct for some reasons that people believe these were humans. So we can compare the interglacials and, for instance, the Holocene, which is here on the left, a typical Holocene stratigraphy. We can compare here with Nemean stratigraphy, both from the same area, from the plateau north of the Alps, from the Swiss plateau north of the Alps. And what you see here is actually a Holocene without agriculture, that this piece here below, and then with agriculture. And with agriculture, you see the openings on top. We are not interested on that. We are just interested in the natural period here. So the hypothesis would say then that the Eemian, where we are sure that we had this big beast still around, would be more open. What you see actually is amazingly the contrary. Usually the Eemian sequences in the same areas of Europe show very closed forests. So the black dots, or actually they are lines, but they are so little that they seem dots. This is open land. These are the herbaceous species. And you see how they expand here with agriculture in the Holocene, or just before. That's late glacial of the Eemian, before the Eemian, and that's late glacial before the Holocene. So that means that the Eemian, despite its mega herbivores, was not more open. The forests were very, very closed. So this is an example. We can reject the Vera hypothesis. This is not true. On the left, this would be according to the Vera hypothesis, that we would have these large mammals affecting and creating kind of savanna. And on the right, you see a picture, I think, from India, actually how it would look like in a temperate ecosystem with these elephants inside. So we would expect something like on the right and not on the left. Why is this important? This is important because the Vera hypothesis is in part used to restore natural habitats over Europe. There are attempts at that with big mammals, so that they try to suppress the forest because they say this is natural. From a paleoecological point of view, this is not true. This we could falsify. So the second example regarding the humans is the long way to today's humanized vegetation of Europe, and especially here in the Alps. Why did I choose the Alps? First of all, I like the Alps, of course. I'm an alpine person. But secondly, because it's a microcosm. The Alps cover all the vegetation belts of Europe. There is no exception. So from the south in Liguria or in southern France, for instance, where we have Quercus ilex, We have, well, it's Meso-Mediterranean, so it's still not very hot, but we have evergreen broadleaf forest in the south of the Alps. We go up through sub-Mediterranean environments with chestnut, and then temperate environments with deciduous oaks, then beech forest, fagus, spruce, picea. Then we go into the larch, and we go in the Arctic alpine meadows, and we go to the ice. So it's the whole Europe just concentrated on a very, very small spot, and ideally for studies. And you see what this picture shows is the today's conditions. Was it always like that? This is one of the questions that we have as ecologists, which is very interesting. And if we zoom back, like in a cartoon, just very simplified on the Alps, we see this picture here. We see a picture which compares the past, about 6,000 years ago. The red dots, which you see here, these are all pollen sites and macrofossil sites. In part, they are macrofossils or stomata sites. Most are just pollen sites. So you see how many they are around, and this is just a little selection along a transect done in the past 50 years. And we can use these sites, the red dots, to reconstruct the vegetation dynamics through the Holocene, through this time. And what emerges from this, if you look at these forests here, simplified just by some symbols, they were more rich, far more rich than the forests that we have today. Usually in the Alps, you have dominance of some single species. So we call that monospecific dominances, like the beech forest, or for instance, the spruce forest. This would be a spruce forest, or that would be chestnut forest in the southern Alps, and so on. Sometimes there are two species codominant, but it's not that we have like 5 or 6 species per belt like we had in the past. So it's really something which we lost. And in the colors you see where there was a resilient behavior in green, where we didn't have much change. We had displacements, complete displacements of communities in the past 6,000 years, and then just adjustments in between. So what happened? What happened? Why was the forest vegetation 6,000 years ago so much more diverse than today in regard to the trees, which are here the question? So what happened is that we had technology of humans that changed very much through time, and we had pulses of land use change with technological changes. And here in the Greek letters, you see some of the big steps through the history of Europe, from Sicily, Tuscany, Switzerland, and other continents that are more natural, just for comparison. On this axis, you see time, thousands of years, and here you see the landscape condition, from pristine, natural, mosaic, unevenly altered, or intensely altered. And you see how through these innovations in Europe, people moved and changed the landscape very much to become intensely altered during the past 1,000 to 2,000 years. So this change, these innovations, which of course are innovations related also to the tools that one can use to change the vegetation, profoundly altered the ecosystems of Europe. I will bring an example from Switzerland about how this happened to be. Human impact here that is exemplified through cereals, cerealia, that would be the crops, and then Plantago lanceolata, plantain, which would be the wheat, as anthropogenic indicators. So this is our proxy for the human impact. And we have 3 sites, Lopsigensee, Mont d'Orge, and Orillo, north, central, and southern Switzerland, or German Switzerland, French Switzerland, and Italian Switzerland. So in these 3, these are also cultural chambers, of course, but they are also ecosystem chambers. In these 3 regions of Switzerland, you see that many things happen related also to fire. So generally, for those records that are continuous, we see a steady increase of fire north of the Alps, in the center of the Alps, and here especially strong south of the Alps in Italian Switzerland. And this is certainly connected, and you see just correlatively connected to some increasing anthropogenic impact that you see in these proxies. What is amazing is how the vegetation responded. So when you have these increases in human impact and the fires, you see that some taxa are strongly disfavored, like Tilia here, for instance, in all regions of Switzerland. And imagine that these regions of Switzerland, you also have Elm here, Ulmus, and Abies are representative for the south of Europe, for northern Italy, and this is more representative for rather continental conditions of Europe, while this is representative perhaps for north of Europe up to Denmark, vegetation-wise and climate-wise. So you see these huge changes in the taxa, and they were heavily disfavored. This is a hypothesis. We can look at the favored taxa. And here, for instance, favored were spruce, picea, and this also beech, fagus. And you know, these are so important species for economy today, but also for the forest, like the spruce forest and the spruce plantations that we use for timber production, especially in the Alps and north of the Alps. Or then the beech forests that have several advantages. Among them, they produce timber, but also the fruits are very attractive. So we see how this action, anthropogenic action, favored apparently and disfavored some of the taxa, just by looking correlatively at the picture through time. So we have here 14,000 years, and we have here the pollen abundances. So it's basically the Holocene, what we see here. Good, so that was fire, but actually if we go back one, I also wrote browsing, so grazing or browsing in the forest. So how can we identify human fires or browsing and the connection in between them? This is done by charcoal, or then proxies that we have like Sporormiella, the spore from a dungal fungi that we have in the archive too, and which are indicative, Sporormiella for browsing or grazing and charcoal for fire. And in time series, we can do time series analysis. This is the numeric part now, where we can explore the hypothesis and do a thorough test for it. Like for instance, here we have the correlation coefficient on this axis. 1 would be maximum, 0 is no connection between the two variables. Charcoal is X, so that's the independent variable. Cerealia is Y, this is the dependent variable. And we just look at several time lags. So lag is a time lag, and these are in this example here, these are 28 years, and we are in the Bronze Age. Important is we have contiguous sampling, so that means we have no gaps in between the samples. We have everything recorded through time. And if you look at that, the time series analysis says that we have a correlation at +1 lag, so that means after 28 years between charcoal influx and cerealia. What does it mean? It means that 28 years after the fires, we have a significant connection with the fires of the cereals. So these are positive lags, this is after the fire. These are negative lags, this is before the fires. One step is always 28 years on the x-axis. So if we do that, like now we look at charcoal. We look at charcoal as a proxy for fire, and we look at Sporormiella as a proxy for browsing. And what emerges here is, yes, there is a significant correlation with the fires at the lag 0, but it increases at lag 3. So it means about 100 years after the fire, we have more intense grazing and then grazing decline. So there is a linkage between the fires and the grazing activities of the animals. As well, there is a linkage between the fires and plantation of cereals, which then connects these two things numerically. So we are quite sure that this linkage is then causal according to our hypothesis. And they are independent. That's also important. So we compare always influx with percentages to avoid internal correlations, spurious correlations between the proxies. So they are completely independent. This effect of human fires that we proved, or we tried to prove, I hope I can convince you that these fires were anthropogenic through the time series analysis of this one example. There would be many more where we see these significant correlations. This effect of human fire on species was selective. Why do I say selective? Because there is, depending on the species, a response to fire which is non-linear at all. So we have to face here non-linear responses, which is very complicated actually, and we see here some models that try to evaluate or create a response function through these generalized additive models for some of the species. This is now macrofossil analysis, this is not pollen analysis we have seen so far before. Juniperus nana, Larix decidua, and Pinus cembra. What does it mean? It means that Swiss stone pine, Pinus cembra, is more disfavored by fire here than Larix decidua. Larch is a little bit more fire resistant, but the species which benefits a lot from fires in this case here is Juniperus nana, so dwarf juniper. So that's a way to show quantitatively how these things are connected so that we can use them actually for ecology, but also for other purposes. So I come to an example which shows the displacement of the original subalpine forest from the Bernese Oberland, just to illustrate how this looks in the original data. So we have on ground, we have the natural forest. They were quite diverse. You see Pinus cembra, Abies alba, Larix decidua, Picea, Abies. So we had here at least 4 forest species together by macrofossils again. Then we have a huge fire here about 3,700 years ago in the macroscopic charcoal, and you see how we lose after this fire here, and we know from the pollen diagram this is grazing activity, we lose this species here. Today at Sakistalsee, at this location, there is just spruce forest. The other forests have gone. So that's one example how it looks like, just very concrete. But we lost some of the species, we have seen that, impoverishment, but what we must also say, overall, biodiversity increased through time. And this is through the creation of open lands. So the legacy effect here is that diversity, overall diversity, and this is species richness, that's a proxy for species richness, which is called paleoecological richness, increased through time. We have again here 14,000 years, and the trends here are very clear from Lopsigensee, which is north of the Alps, to Lago di Origlio, which is in Ticino. You see how richness, overall richness of the open habitats increases. So it's not to say that humans just created a kind of destruction in the forest, they also provided place for species. So the effect of human fire disturbance also on the structure, not just species composition, was huge. Here an example from Sicily, where we see it for the period 2300 BC to 800 AD. So it's quite a long period. Statically now, that would be lag 0, just lag 0 at the time of the fires, not after the fires. We see what happened in this period. Correlation coefficient showing the linkage between some taxa here that increase with fire and very drastically. So correlation coefficient 0.9 almost for Camerops humilis, the European fen palm, and other mucky elements. And what is disfavored in Sicily, in coastal Sicily here, are the evergreen forests. So structure change from evergreen broadleaf forest to mucky. And we can do that for other areas too. We can look and check for now Ticino, which is representative also of northern Italy. And we see the expansion of shrublands here. That's in the period of the Neolithic, and this is Bronze Age to early medieval. We see first shrublands like with Corylus or Salix and Pteridium that expand. The forest is disrupted, and then later on the grasslands. That's again from the Bronze Age to the early medieval, like we have seen at Borgo Basso in Sicily, how huge these effects are of the human fires. So they create this later on in the Bronze Age and after this open land that is mostly for grazing, before we have these shrublands. And if we go north, basically the same picture emerges also for Central Europe. That is very comparable to Ticino, shrublands in the Neolithics and open grasslands. And certainly the the forests that are disrupted, and in the Metal Ages, then you see that the shrublands are disrupted. So it's an increasing openness of landscape that provides this ground for the species. So now I would like to go to the last example, which is a more detailed example from Abies alba. What you see here are sites along a transect. Oh, sorry, something happened. So yeah, what you see here is a transect, and important are these crosses there. We lost Abies alba from the forest, so these are local stations. But what happened? If we go to the details, that's an ordination analysis. There is a moving from the past. These are these colorful dots. The colors are the sites, and the crosses, that's the present. So this is about 6,000 years ago, and this is today. And we move along axis 1 and axis 2 of DCA, of the trended correspondence analysis. And what you see is the moving along this axis here for Abies alba. So that's the slope from 60% of Abies alba down to 0% of Abies alba in this direction, which is the present. So basically it shows the extinction. That's a slope which shows the extinction. On the other hand, from the same sides with the same colors, you see the cereals. That is actually the inverse. So you see a mountain that increases. The more cereals we have in the records, the less Abies alba we have. And plantain, Plantago lanceolata, again, as an indication, a weed which is expanding with human impact. The interesting thing here now is that human impact is on axis 1, so is more important in the ordination analysis than actually climate. How do we know about climate? You see the Alps here, Swiss plateau, northern Italy, central Italy, and southern Italy. So this is the temperature gradient. We can locate that through the sites which reflect the geographical pattern of Europe. What does it mean? We lost some Abies stands here. This is clear. They are extinct now, they don't occur. And if we look at the sites, these are the warm-loving places that we lost it in Ticino, northern Italy, central Italy, and southern Italy, lowland stands. And here, alpine stands. I brought the example with stone pine, Pinus cembra together, and larix, and so on, where Abies was also growing. And you can imagine this is the climatic niche of the species in regard to annual precipitation on this axis and temperature on this axis. So we would have here the temperature and the precipitation niche. And what you see is the temperature niche is reduced. It's reduced today. That's the center where the species is very strong. We wouldn't know that the species can cope with cold conditions or actually very warm conditions. So this affected really the niche. So now one may say, okay, Abies alba, we know Willy is a little bit fixed with this species. He has published a lot, is an exception, but it's actually not like that. We can do that for many different taxa. Some have reduced niches like Ulmus, Tilia, Acer, Fraxinus, Ilex. I have shown that actually with that picture where we had seen the transect through Switzerland, while others have anthropogenically widened climatic niches. So what happened is that people stretched the niches. They gave advantages, competition advantages for those species they were interested in. Some you recognize they are fruit trees like Juglans or Ole Europea, Corylus, Avellana, and some others produce nice timber. So we helped very much those species and we disadvantaged those species here. So what is the relevance now of these legacies for the future? I will come in the last minutes I have to this. We can address this question by using dynamic models that are very good for scenarios, for future scenarios. And we focus on dynamic models because they can simulate through time. So they are not static or correlative, and they are based on ecophysiological traits of the species. So here an example from Tuscany, because Pisa is in Tuscany, you all know that's from Massachusetts, one of our study sites. And what you see here bottom down is a very simplified pollen record through the past 7,000 years. And you see at some point in time, there is this special Abies alba Quercus ilex forest that has vanished. That will be today. That's a reflection of the today's forest communities at Massachusetts in the year 2000. So if we now simulate on the present climate what the model is doing, just the model, this is a simulation, we see that if disturbance is low, surprisingly, after about 200 years, at least in the model, these gone or extinct forests, they reappear. While if the disturbance stays moderate, like it is today, these habeas alba forests have no chance to appear. And that's actually how the model explains the difference between the past and the present. It's just disturbance, according to the model. Here in the model, we have browsing and fire, which are driving this different scenario. Now we go to the future climate. And what you see in the future, it's about 4 degrees warmer. You could compare here in more detail. Also, the precipitation changed here. What you see in the future is a vegetation type which emerges, which is different for low and moderate, but still similar to the today's condition. Now we move a little bit more north. We go to Ticino, and there we see again the pollen diagram here covering the past here 10,000 years. And you see that the model for today, if disturbance, browsing and fires is low, can simulate the resurrection, so to say, of these habeas alba forests that have gone. They are not present today. Here you see today. But if we increase disturbance, then they don't appear. They have no chance if we keep moderate disturbance. And now there is an ecological surprise. If the climate is warming for 4 degrees Celsius above, we see what happens. Habeas alba is overshooting in biomass. This is simulated biomass, something we wouldn't have expected. We thought it's going down like we have seen in Tuscany. No, it comes up and it builds really almost monospecific forests with some model. If disturbance, however, in the future will be moderate, then there will be an invasion by Mediterranean species like Quercus ilex, a vegetation which resembles what we had in the past in Tuscany, which was very amazing to see that in the simulation. Good, now we could apply these models to the European scale, and of course we can do the same. We validate the simulations by looking at the present. That's a distribution map of habeas alba for the present. Black is realized, green is what could be the potential, and we can check the simulation for today with the information from today, which is quite good. We can go in the past and check that. How is the model doing in the past? Where we have this axis, there is no habeas alba pollen, and where we have the dots, there is, and we see the simulation is doing quite well from here, from the Caucasus to southern France, and for Iberia, the pollen says there is no habeas, but perhaps we miss here the Pyrenees, actually where habeas was. This needs to be investigated. So we are quite happy with these simulations, and if we are happy, we can apply that. We call that a paleo validation. We can apply that to the future. And what comes out is if temperature increase by 2 degrees Celsius on the continent, the foliar coverage increases here. That's amazing over Europe. And you see where it increases in blue. That's mostly in the center and in the east. While if we have warming of 6 degrees, it stays more or less stable. And you see where the populations of habeas alba are most in danger. And of course, that is in the south of Europe. But here we lost most anyway, so through human impact. Anyway, many thanks for your attention. Thank you for listening. Here, a last example of something that is unknown. This is from Tuscany, close to Pisa. Actually, habeas alba stand with Olea Europea, Laurus nobilis, and Quercus ilex in the forest. Thank you.
Thank you very much, Willy. Grazie, Willy. Thank you for the presentation, which is extremely clear and well done, very didactical, and also I think there is a lot of question, a lot of curiosity from the public, probably, but also from myself. So I don't know, I would like to open the discussion. Are there any questions, please?
Anche in italiano, le domande si possono fare.
Sì, le domande si possono fare anche in italiano, sì. Però ho visto, I've seen there is also foreign people, so a colleague from outside. So.
Okay, sorry then. Yeah, English.
Vedo Manuel Tiburtini che si è alzato la manina, può accendere il microfono e può parlare, ne ha facoltà.
Hi, thank you for the nice presentation. It was very interesting. And I have a question about the slide 26, in which you talked about hedera that was reduced by anthropogenic factors. And the question is, I know that hedera is a species that cover the forest where disturbance is moderately or intense. The question is why in that slide hedera was considered reduced by anthropogenic factors.
Yes, so this is on the basis of the paleo evidence, first of all, and it's over the centuries. And one must say it's just reflecting the flowering. So it's not biomass, this one is pollen. And you know that hedera needs time to produce pollen to grow up and reach the canopy in the forest. So in the forest where this hedera actually was growing, we know there was the hedera, the species needed a lot of time to go up and actually go to the top of the canopy. That's the explanation that we have. Once the forest was disturbed, then disturbance regime was so high, hedera was still there, certainly, but probably the pollen production was reduced and we didn't have these big hederas, lianas growing up in the forest like we had on the natural conditions.
Thank you. I see Laura Sadori. Laura Sadori, it's a question from Laura.
Yes, grazie Willy, ciao.
Ciao Laura, ciao.
I just wonder, you were speaking in your last slides about fur, about Abies alba. What about changes in precipitation and the humidity? What do you expect in the case of sudden change of this kind, the climate, I mean?
Yes, exactly. So we always also include the moisture because this is the other very important thing. So temperature is just one part, and sometimes moisture, especially in the Mediterranean, is even more important. So for instance, at Massachusetts, you see on this slide here that I presented that we also included moisture so that we are sure what's going on. And in the future at Massachusetts, you see that probably it's getting too dry for Abies alba. You see under the low disturbance regime here on the present condition that Abies alba is doing well, but still low. There is almost no disturbance. Abies alba is not able to cope. And this is certainly not temperature. This is moisture. So here moisture, which is getting then, that's a mixture between the precipitation, of course, amount in millimeters, and the temperature is too much reduced. And we are sure that if we have lowland stands today, cryptic one in Tuscany, we would lose them. And this was also in the final slides of Europe, where in the south you had these red dots for Abies alba, where it's actually gonna extinct if there is still some around. So moisture is very, very important. So this here in the south is mostly moisture, which drives these red points here.
Yes, I fully agree. Thank you.
Yeah.
Thank you, Laura. Grazie, Laura. Se puoi togliere la manina. So, are there any other questions? Maurizio Persico, prego.
Okay, thank you very much for this very clear seminar. I'm not a specialist, so I appreciate it so much. And I've got a general question. To what extent the results of these studies are taken into account in current practice of forest management throughout Europe? And in particular, the ability to run simulations, as you showed in the last slides.
Yeah, so these are in part, of course, models that are made by people from forest ecology, so engineers in part, not all, but Langklim was developed by at ETH. This is this one, which is a Politecnico federal one that is actually very much concerned with practical applications. And actually, to prove that there are practical applications, proof of concept is, I'm searching for the Conedera slide, because the one publication here, that one, this comes from a forest engineer. So this one is from Marco Conedera, who is really concerned with local things in the forest outside in Italian Switzerland, and has seen this paleo data and has tried to show them to people, forest managers and forest ecologists, so they understand paleoecology. So some people then get so interested outside in the forest management that they try really to take out this information that is relevant. We, of course, are in discussion with them, so we try in a way also to apply the knowledge from forest ecology and from forest management to understand better what happened in the past on the human impact, for sure, but also on the natural conditions. So I think this is an exchange of concepts, of ideas, which is extremely important also to convey the message of paleoecology to the practitioners, to the people that are really outside and responsible for the management of our forests. So I think that's very, very important.
Thank you. I'm happy to hear it.
Grazie Maurizio anche per la domanda. Se puoi togliere la manina. Angelino Carta, vedo un'altra mano alzata.
Yes. Thank you for the seminar. It was quite interesting. I have a question. If I correctly understood, there is a projected variation in the flora in the two sites. So in the Massachusetts sites compared with the South Switzerland side. And my question is whether this is the result of a higher climatic change expected in the two sides, or whether the current flora is already more adaptable to future changes. Let's say that the current flora in the two sites have a larger optima or larger niche response to the climatic variation. Thank you.
Yeah, thank you for the question. So it's both, actually. So what you see here is driven by climate changes that we simulate in the background, and this then is acting on the species, how they are defined. So what's in the model? In the model, there are the life traits of this species, so their ecophysiology. So actually what has been measured in experiments and observations, how tall is a species growing? How much shade does it generate? How much shade does it tolerate? How long is the life cycle? When does it get maturity? And all these things, light needs, nitrogen needs, they are all in this model. So these are all niches, basically. All the niches of the species, as long as we know, go into this model, and they stochastically then interact. So it's really a holistic simulation of the ecosystem. So this is certainly inside, and the climate is then added. So these are the parameters that do not change. They are evolutionary fixed for the species. And in the model, what we can do is then on this, we add and change the climate through time. So we can do variables, climate variables that act on every step. This is then the variable which changes. So both goes inside, and it explains these drastic responses. Mixture between climate response and the niches of the species, or the traits of the species that are in the model. Both, of course, is not reality. It's according to what is known in the literature. How do we do that? These are years of work for the Mediterranean, 10 years in our section of a postdoc that collected from Pignati, from Greece, from everywhere, what is known about the Mediterranean species and put them inside the model. So it's quite a huge work, but I think it's then getting more and more realistic.
Thank you again.
Sorry, just so we cannot conclude that the Mediterranean plant species have a broader niche or a broader possibility to adapt to future climate. So this is not possible to conclude.
No, I think this is not possible to conclude. We just don't know, actually, about what is the, and then it depends, is it the realized niche or the fundamental niche? So in regard to the realized niche, as I said, what we see today is not natural. The people change these niches. And the fundamental niche of the species, that means what is the physiological tolerance without competition of the other species. This is more difficult to measure for trees under laboratory conditions. And there, I think we just don't know exactly if we compare temperate, boreal, and Mediterranean species. Yeah.
Thank you very much.
Are there any other questions? In case I have a couple, Willy. The first, my first question is more general. So this is my personal feeling, but my impression when we use, for instance, ecological data or pollen data to reconstruct paleoclimate in terms of absolute temperature and so on. So you show has it's probably really difficult to use this kind of data to reconstruct temperature or precipitation, because during time there is a big changes in the kind of vegetation. So it's actually the actual vegetation, the present vegetation is not a good proxy for the past, for what I understood, at least it changes. And the second point is concerning the Vera hypothesis, which actually is not my field. But I'm wondering if probably stage topic 5e, I mean, the Imian is not probably the best analog for to compare with the Holocene, maybe, but I understand the older interglacials probably have a component of vegetation, which the niches of vegetation, which is too different compared to the Holocene. So I'm wondering if this kind of approach can be done also on much older interglacial to look if there is any evidence of this, because actually the structure of the Imian, the insolation curve for the Imian is quite different compared to the Holocene.
Yeah, thank you. Yeah, so in regard to the first one, that's a hot topic. Huh? Not
yes,
everybody.
I know. I don't want to be polemic. Absolutely not. Yes, for sure.
So as a half Swiss, I should stay diplomatic, probably.
Okay, good. Okay.
But I can say I belong to that school that strongly believes that pollen in the Mediterranean, maybe in the boreal biome, it's okay for climate reconstructions. But in the Mediterranean, where we have this long-lasting human impact that changed the niches of the species, you are completely right. And in the temperate biome, we are in between, but still I wouldn't touch pollen for climatic reconstructions. While for Imian conditions or boreal conditions, one may think about. So it's not a yes or a no. I think we have to be very careful where we are applying. North America, pollen would be probably okay. But this would then need, like you say, to take into account the 2 days vegetation change. So it's very difficult to make your calibration set in the current landscape, which is altered by human impact, and then apply it back to natural conditions. So this is very, very difficult. I believe we have better proxies than pollen for climate reconstruction. The chironomids or the oxygen isotopes, deuterium, and lake level. So there is a full. Why should we use pollen if we have all the other ones? Well, one may say pollen sites are so many, so this is the advantage. But yes, many wrong ones doesn't make it better. So now I was not diplomatic anymore. Sorry, that was probably my Italian part coming out of me. The second question about the Imian, that's a very interesting one. What I showed for the Imian, you're completely right, that's the closest in time. And it's very interesting because it's warmer than the Holocene. So we see a little bit what could happen if the conditions are 3 degrees warmer, about a little bit more moisture. So it's also a little bit more humid. The other interglaciers like the Holsteinian or even further back, Miss 9, 11, and so on, they show the same pattern. So the forests were always closed. So we are quite sure that this Vera hypothesis not only doesn't apply for we can falsify it for the Imian, but also all the other interglacials back that we have data about in Europe. Yeah.
Thank you very much. I don't know if there are any other questions, I think there is a time just for another. Just to give you some data, I mean, there was more than 70 people applied to these teams, and probably, I don't know if Bernardo can give us an information about the YouTube number of, sorry, I'm very proud of the number of participants, so that means it's a very successful, Bernardo, yes.
Sono un'ottantina di riproduzioni.
So, more 150 people participated.
No? Nessuna domanda.
Ok, nessuna domanda, thank you. So, I think voglio dire grazie a Willy per questo seminario veramente chiaro, veramente interessante. Anzi, io spero che Willy voglia ancora continuare a lavorare sulla Versilia. Noi come Dipartimento abbiamo vari progetti, quindi sarebbe molto bello, e soprattutto anche in previsione di quelle che possono essere prospettive future. E soprattutto vi ricordo, vi arriverà presto un altro invito. Il 26 ci sarà un altro seminario, credo su dati ancora più freschi, ancora più vicini a noi sull'Appennino tosco-emiliano. Quindi questi dati sono sicuramente per molti di noi importantissimi, vitali e soprattutto di estremo interesse. Quindi io ringrazio i partecipanti, ringrazio tutti quelli che sono impegnati nella pubblicizzazione dell'evento, tra cui anche, devo dire, abbiamo fatto insieme anche alla Triennale di Scienze Naturali e Ambientali, il CIRSE, che l'INQUA, e ringrazio Willy e a presto, vi saluto e grazie ancora per la partecipazione. Se si può fare un applauso a microfono aperto a Willy.
Grazie.
Io vi devo salutare perché devo muovermi subito su un altro link perché ho il consiglio. Comunque ci sentiamo presto, Willy. Saluto tutti di nuovo. Vi abbandono.
Grazie ancora, grazie mille.